I will just wait for another 30 seconds, 30 or 40 seconds for people to come, and then I'll start the session. I hope you have no doubts regarding the previous the topic, that is the age related questions. Today we'll be covering another topic called time, speed, distance. So I guess I'll start the session today's session. Okay. The basic of before starting the session, let's cover the basics of time, speed, distance. So the very basic is what is speed. So you can note down these things, and once you're solving, or you can revise it later, and it will also be helpful once you're solving the questions. I'll even cover the basics again while solving the question. The first basic aspect is speed. Speed formula is speed is equal to distance upon time. The distance covered upon time taken. So this is the most basic formula, and you have to always remember this. You can also write S is equal to d by t, distance upon time. This is the very basic and the very first formula that we encounter in this topic. And then after that, we have average speed. Average speed, the basic formula or the definition of average speed is total distance traveled or total distance covered. Total distance covered upon the total time taken. Total time taken. So I'll not be discussing any shortcuts in this sessions. Shortcuts can be developed once you are very fluent with these basics. So I would normally stick to basics, and I would also suggest you not to go for the shortcuts. You learn the basics, try to solve the questions using the basics, and once you are very thorough with the basics, you can develop your own shortcuts. That's not a problem. So please note down these formulas and these concepts in a separate sheet of paper so that you can refer these things when you are solving the question. The third part is when two objects are moving in the same direction. So what happens is, for example, let's take an object A and object B. And this is moving in this with the speed s1, and B is moving this direction with speed s2. So that if this distance is d, and what we do is, whenever we are in this kind of situation, we subtract, or they take the difference of the speeds, s1 difference of s2. And for example, if A is moving at 20 km per hour, B is moving at 20 km per hour, and A is moving at 10 km per hour, and this distance is 50 kilometers, the distance between these two, the gap that is reducing will be 10 km per hour. It is 20 minus 10. This is the relative speed of these two. So what we do is, normally in physics, what we do is, whenever we are calculating the relative speed of any object, so we normally tend to stop that object. For example, in this case, B is traveling like this. If I represent it as a vector, and A is traveling in this direction, and if I want to calculate this speed of A with respect to B, what I do is I stop B. So if I have to stop B, for example, B is moving at 5 km per hour. If I have to stop B, if for example this is moving towards east, I have to add another vector here, that is 5 kilometers per hour to the west. Like when you add this side and this side, it becomes totally zero. So it's almost like B is in standstill. But if we are adding this vector to this value here, we have to add the same value here also, 5 km per hour. So hence this difference, for example, if this is 15 kilometers per hour, A is moving at 15 kilometers per hour, the effective speed will be 15 minus 5, that is 10 kilometers per hour. So whenever the object is moving in the same direction, we subtract the values. And if the object is moving in opposite direction, this part, if the object is moving in the opposite direction, then the distance reduces at a faster rate. So if this is S1 and this is S2 and if this is D, then the distance between these two will decrease at a faster rate and the effective speed is S1 plus S2. Here this is S1 minus S2 or the difference between S1 and S2 in this case. So this is D by T. This is total distance upon total time taken. And this is S1 difference of S2. And this is S1 plus S2. And the fifth concept is whenever whenever you face questions like a person is swimming downstream or an upstream. Let me just use the sheet here. While swimming, if a person is swimming, see, for what happens is this is river and he may be swimming like this in this direction. So if river is not moving, if river is it's like a lake and the water is not moving, and this the swimmer may be swimming at v meter per second. Okay, and if he is swimming and if the river has a velocity, for example r meter per second, and if he is swimming downstream in the sense, downstream means the person is swimming in the direction of the water. So if the water, this is water direction, water is flowing in this direction, and the person is also swimming in this direction. So this is in the same, both are in the same direction. That is called downstream. If a person is swimming downstream, then both the water and the swimmer is in the same direction. In this case, we add these two, v plus r. So the effective speed velocity would be v plus r. And if the swimmer is, for example, the river is flowing this side, this is river, and the swimmer is swimming in the opposite direction. He's swimming in the opposite direction. This is called upstream. He's swimming upstream. In this case, we would minus it. And in this case, normally what happens is if the swimmer is, is moving in the upstream direction, if he's able to move on the left side, that is in the upstream, his velocity would be more than the velocity of the river. Only then he can move on the upstream direction. If the velocity is not more than the velocity of river, he will flow with the river in this direction itself, in the reverse direction. So this is one concept that you have to note down. So when the swimmer is swimming downstream, it would be v plus r, where this is the swimmer's velocity and this is the reverse velocity or reverse speed. And in this case, when he's swimming upstream, that is, in that case, we take v minus r. V is the velocity of the swimmer or the speed of the swimmer, and r is the speed of the river. River flowing in this opposite direction. This is one concept. And there are also problems where they give about a train. So, for example, in one case, what they do is they'll make a person stand here, and the train is passing. The train is passing here. Okay, and the train's length is L. So what they do is, so whenever the person is standing and the train is passing, the distance traveled, when we use this speed formula, distance traveled upon time taken, the distance is nothing but L, the length of the train. So we say that the train has started passing when the front portion of the train is at the same, the same line with the person. And when we say that it has already passed this, that it becomes this is the last portion and this is the engine and the last bogie. So this length is the length of the train. So this is when we say that the train has completely passed from the, so the engine reaches the person and then the last bogie crosses the person. So that whole length is L. The distance traveled by the train would be L. So when we are doing the questions, we will understand this concept clearly. And in this case also, if the person is standing, we will not consider the person's velocity or the speed. If the person is moving, in the direction of the train, we will subtract the speed of the train and the person. If the person is moving opposite of the train, if the train is moving this side and the person is moving the left side, we add the velocity or the speed. Okay. And there is one more variation in this type of problem. What they do is they'll say there is a platform here and the train is approaching the platform. The train's length is L1 and the platform's length is L2. And they'll say what is the time it takes for the train to cover this platform. So to cover this platform, the engine first has to traverse this distance L2. It has to cover this distance L2, and then this last bogie also has to cross this platform. So this becomes L1 here. So the total distance traveled would be L1 plus L2. So for example, in this case, if you take it as 100 meters and this is 150 meter train. So 100 meters is the platform length and 150 meters is the length of the train. So the total distance covered by the train to cross this platform would be 150 plus 100. That becomes 250. So you should remember this. So these are some of the variations of the questions that are normally asked in CSAT and other UPSC exams. And as and when we go through the questions, we'll cover each and every concept again. So we'll always solve the question from the basics. So I hope you have noted down all these, the formulas and the basic stuff. And if you are done with this, if you don't have any question, I'll move on to the questions, today's questions. If you have any doubt, please do ask. Please raise your hand and ask your question. If you have any doubt in the things that we have covered till now. If there is no doubt, we'll start with today's questions. So we'll follow the same format. We'll solve some of the questions of UPSC previous year's questions, that is from different exams. And after we have got used to solving these questions, we'll then move on to CSE questions. If you have any doubts regarding the concept that I've covered now, you can ask now, or else we'll move on to the questions. I'll wait for 30 seconds. If there is no question, we'll move to the questions. Okay, we'll move to the questions now. So we'll solve today's question. This is today's question. Please take 3 minutes or less than 3 minutes to solve this question. Okay, the time is up. We'll try to solve this question now, and I have created the poll. If you please select the options that you have got. So around 56% selected option D, and 44 selected option B. So If you are still solving, you can take another 10 to 15 seconds to solve. Around 20% option A, 27% option B, 6% option C, and 47% option B. Okay. So we'll see how to solve this question. The question says that a scooterist completes a certain journey in 10 hours. He covers half the distance at 30 km per hour and the rest at 70 km per hour. What is the total distance of the journey? So just like we have used the tables in the age related questions, we can use the table here also so that everything becomes clear. Once you get used to the table, your concepts will be very strong. Everything will be clear and organized. So what we do in this chart is one column is speed, the other column is time, and the third column is distance. Okay, this is the row. This is how we divide this. So what we do is, in these kind of questions, we take S1, S, T, and D is S into T. This is the distance. Speed, so we have the speed is equal to distance upon time, and distance is equal to speed into time. So that is what we have done here. So this is how we write the table. In this case, so let this be here as an example. So what they're saying is he covers the half the distance at 30 km per hour. So the speed is 30. So always be see whether the units are same. Here it's 30 kilometers and 70 kilometers, and the time also is in hours. If it is not in hour, we have to change the units. So this is 30. Time they have not given, but distance they have said, let the time be t1. Distance they have said it's half. The total distance half. That is d by 2. And the second thing they are saying is another half it has covered in the scooterist covered in 70 kilometers per hour speed. The speed was 70. At the time he had taken is t2. And the distance is same. They are saying it has. He has covered the same distance, equal distance, but in different times and different speeds. So what we can say from here is, and they are saying that total time taken is 10 hours. So we know now T1 plus T2 is equal to 10 hours. And this is one equation. And what they're saying is this distance also is same. So 30 T1 is equal to 70 T2. So T1 is equal to 70 by 30 T2. This is 7 by 3 T2. What we have to find out? We have to find out D. Always remember this, not D by 2. We have to find out D. So input this value of T1 here. It is 7 by 3 T2 plus T2 is equal to 10. So this can be taken as 7 by 3 T2 plus 3 by 3. Like instead of taking LCM, I'm writing it like this. This is 10 T2 by 3 is equal to 10. 10 and 10 cancels. T2 is equal to 3 hours. And T1 is equal to 7 hours. And what is the distance? D by 2 is 30 into T1 is equal to D by 2. Now we know T1 is 7 hours and this is equal to D by 2. This is 210 equal to D by 2. D is equal to 420 kilometers. Like we have multiplied this 2 here. So D is equal to 420 kilometers. The option is C. I hope you have understood this. If you have any doubt, you can raise your hand and ask a question. Please, if you have any doubt, try to clear the doubt here itself. I hope you have understood this. So if no one has any doubt, we'll move to the next question. Okay, we'll move to the next question. Please take around 3 minutes to solve. The time is up. Please select the options in the channel, the options that you have got. I'll give you 30 seconds, 30 more seconds to select the options. And once you're done, I'll start with solving the question. So there are around 10 votes, 20% for option A, 50% for option B, and 10% for option C, and 20%, okay. 47% have selected option B, and 29% have selected option D. So let's see how to go about this question. So the question is, a train 200-meter long fully passes a platform of 200-meter length in 15 seconds. What is the speed of the train? So what we have to calculate is the speed. So please mark it here and circle it so that you don't forget. You have to calculate the speed. And the basic formula for speed is distance upon time. And in this case, the platform length, let this be the platform, and this length is 200 meters. And the train is about to pass. Let this be the train. And this is also 200 meters. This is 200, this is 200. So if it has to cover, I mean, when it covers completely, when it passes the platform completely, this would be the exact photo of that instance. This is 200 and this is 200. So the train has to pass this 200 and then the body has to go away from this platform. So this would be total distance would be 400. And so the speed is nothing but distance traveled. In this case, it is 400 meters. Okay, and the answer is in kilometer per hour. So this is 400 meters divided by time is, it has taken 15 seconds to cross this platform. It is 15. And this is seconds. And to convert this, what we do is meters. So we know that 1000 meters is 1 kilometer and 3600 seconds make an hour, 1 hour. So this 400 meters, to convert it into a kilometer, what we do is we divide it by 1000. This will be a kilometer. And then this 15 seconds, to convert it into hour, we divide it by 3600 seconds. So this would be in kilometers and the denominator will be in hour. Normally what people say is, for example, here it's 400 by 15 into 3600 by 1000. And if you simplify this, this becomes 18 upon 5. This is like, for example, these two zeros cancel, 2 5s are 2 18s are. So this is 18 upon 5. This is 400 by 15 into 18 by 5. So you can simplify this. So this is 3 5s are, this 3 6s are, and then you have 5 8s and 80, and then this is 5 6 are. This is 96. 16 6 and 96, and the answer is D. If you have any doubts, please do ask. I hope I'm clear. If you still have any doubts, please raise your hand. I'll clear your doubts. I hope your doubt is cleared. Okay. If there are any doubts, please do ask, or else we'll move to the next question. So there is no question, then we'll move to the next question. So please take 3 minutes to solve. The time starts now. I selected B. So let's see what's the answer. So in this question, what it's saying is a person goes from a place A to place B at the speed of 4 kilometers and returns at a speed of 3 kilometers per hour. If he takes 7 hours in all, then what is the distance between the two places? So this, okay. So there is this place A, there is this place B, and the person is going from here like this, and again coming back to this position, and we have to find out this D. Okay, so we'll first set up a chart: speed, time, and distance. We have the speed, time, and distance. So from A to B, he's going at 4 kilometers per hour. And let the just check the units here: kilometer per hour, and hour. So, and even the answer is in kilometers. So everything matches. So the time, let the time be t1, and let the distance be d. So he has covered this distance at 4 kilometers per hour. He has taken t1 time, and the distance is d. Then while coming back, his speed is 3 kilometers per hour. Let him take t2 hours, and again the distance is d, because he has covered the same distance, and that is t. And what they are saying is, if he takes 7 hours in all, so he's going from A to B and again coming back to A, he's taking 7 hours. So t1 plus t2 is equal to 7. And we also know that 4t1 is equal to 3t2, because it's both are equal to d, for example, and this is equal to d. So we know t1 is equal to 3 by 4 t2. Substitute the value here. So we have 3 by 4 t2 plus t2 is equal to 7. And this can be written also as 3 by 4 t2 plus 4 by 4 t2 is equal to 7. And then this is 7 by 4 t2 is equal to 7. 7 and 7 got cancelled. t2 is equal to 4 hours. And t1 is equal to 3 hours. And we need to find out d. So you can find out here itself. Like 4 into t1 is equal to d. So we have found out that t1 is 3. That is equal to 4 3 is 12. You can even find out this way: 3t2 is equal to d. T2 is 4. 3 into 4 is equal to d. That is 12. D is equal to 12. And here also d is equal to 12. So the answer is A. This is about a man rowing down a river. I hope you can see the question. Yeah. So please take around 3 minutes to solve this question. And the time is up. You can select the options that you have got in the channel. I'll give you 30 seconds to select the options. If you have, and if you have still not able to, if you're still solving the question, please take another 30 seconds to solve it. And then after that, I'll solve the question. So we have got around 22% people have selected option B, 56 option C, and 22% option D. So we'll see how to solve this question, what is being asked. So in this case, as I discussed in the the basics part, this is about a man rowing. He's in actually a boat and he's rowing down a river 18 kilometers in 4 hours with the stream and returns in 10 hours. So let's say this is a stream from A to B. The water is also flowing this way and the boat is also flowing in this way. And let the water speed is x and his speed is y. Okay, so let the water speed be x and his speed is y. In this case, or we can take this as y and x. It's not an issue. Let the person's speed, the speed of the rowing be x. And the river speed is y. So what they're saying is he went down and it took 4 hours to reach this 18 kilometers. And then he again came back in this direction. And while coming back, he took 10 hours. This is 10 hours and this is 4 hours. So we'll make a chart here. Speed, time, and distance. So in the first case, when he is moving down the river with the stream, the speed gets added. So it becomes x plus y. Time he is taken as 4 hours and the total kilometer of the river is 18. And when he is coming back, the speed, you take the difference of the speed. So when the person's speed is x and the river speed is y, so x minus y, and he's taking 10 hours, and again the distance is 18. So this we have two equations now. 4 into x plus y is equal to 18. 4 into, this is 10. 10 into x minus y is equal to 18. Now if you multiply this, 4x, or you can cancel, can reduce this equation again, so that it gets simplified. This implies 2 into x plus y is equal to 9. Have like 2 2s and 2 9s, and then 5 in this equation can be simplified as 5 into x minus y is equal to 9. So we have these two equations, 2x plus 2y is equal to 9, and 5x minus 5y is equal to 9. So we need to eliminate one variable here. So for that, what we can do is we can multiply this equation by 5 and this equation by 2. So we get 10x plus 10y is equal to 45. 10x minus 10y is equal to 18. So we eliminate this. We have 20x is equal to, this is 63. This is 63. And x is equal to 63 by 20. This is equal to 31.5 by 10 is equal to 3.15. So x is 3.15. What is x? X we have taken it as the person's speed. X as 3.15, and we need to calculate the speed of the river. So we can input it anywhere here. So in this, let us input it here. 2 into x is 3.15 plus y is equal to 9, and 3.15 plus y is equal to 4.5. y is equal to 4.5 minus 3.15. So that is, this comes down to 1.35. So we have y is x is equal to 3.15 and y is equal to 1.35. Okay, and we'll see what are the statements given. The speed of the man against the stream is 1.8. Against the stream means if he is coming back, that is x minus y, that they're saying is 1.8. So this x minus 5 is, in this case, it's 9 by 5. Sorry, 9 by 5. This is equal to 1.8. So this speed, if he's now rowing against the stream, his speed would be x minus 5, and thus that value is, in this case, from this equation, that is 1.8. 9 divided by 5, x minus 5 is 1.8. This is a correct option. The speed of the man in the still water is 3.15. So the speed of the man in still water is 3.15. And the speed of the stream, the speed of the river, that means that is 1.35. So all the three values, all the three statements are correct, and hence the option is D. I hope you have understood this. If you have any doubts, please ask. Please take 3 minutes to solve this. The time is up. You can select your options in the channel. I'll give you 30 seconds to do that. So 57% have got A, 30% have got B, 20% have got C, and nobody has got D. Okay. We'll try to see how this is done. The question says that a man traveled 12 kilometers at a speed of 4 kilometers per hour and further 10 kilometers at a speed of 5 kilometers per hour. And what was his average speed? You need to calculate the average speed. So circle it, and in the question paper also do the same thing so that you don't forget what you need to find out. And just check whether the units are same. Kilometer per hour, 10 kilometers and 5 kilometers and per hour, and even the options also have same units. So you don't have to worry anything. So we'll draw our chart here. We have speed, we have time, and we have distance. And we know that average speed is equal to total distance upon total time taken. So what they've said is a man traveled 12 kilometers at a speed of 4 kilometers per hour. So his distance was 12, speed was 4 kilometers per hour. This was 4 kilometers per hour, and let this be T1. And the second is he traveled further 10 kilometers at a speed of 5 kilometers per hour. Let this be T2. So we know that speed is equal to distance upon time. And here in this first case, the time is equal to distance upon speed. And first case, distance is 12 and speed is 4. So T1 is equal to 3 and T2 is equal to 10. The distance is 10 and the speed is 5 and the time taken is 2 hours. So total, now we need to calculate the average. Average is total distance upon total time. The total distance is 12 plus 10 and total time is 3 plus 2. T1 plus T2 is equal to 5 hours. This is 3 plus 2 is equal to 5. This is 5. This is 22 by 5. This is 4.4. So the correct option is option A. I hope you have understood this. If you still have any doubts, you can ask. If you have any doubts, please ask, or else we'll move to one more question, and then we'll close the session today. Okay, we'll solve one more question. So please take 3 minutes to solve this. Around 43% have selected B, and 29% have selected the option D. We'll see how to solve this question. So what they're saying is that a train takes 2 hours less for a journey of 300 kilometers if its speed is increased by 5 km per hour from its usual speed. What is its usual speed? So we have to find the usual speed. Let that speed be S. Mark it here. Speed, time, distance. So let the usual speed be S, and the time taken is T1. Distance is 300 kilometers. And they are saying that if the speed is increased by 5 kilometers, then its usual speed, the train takes 2 hours less. So if this is S plus 5, and then we have T2, what they're saying is, so this is, let the time, new time be T2. What they're saying is T1 is minus T2 is equal to 2. So if they're saying that if the speed is more, the time taken would be 2 hours less than the normal time. This is T1 minus T2 excuse me, is equal to 2. This is one equation. And T1, you can, S is equal to D by T. So this is T is equal to D by S. So this is T1 is 300 by S minus T2 is 300 by S plus 5 is equal to 2. We take an LCM here, and S into S plus 5. This is 300S minus, S plus 5, 300 into S plus 5 minus 300 into S. This multiply and this multiplied. So what we do is, we take this fraction and we multiply it with the LCM, S into S plus 5, and this is S, sorry. So SS gets cancelled. The remaining part is 300 into S plus 5. That is what is here. That is equal to 2. So we have 300 S plus, this is 1500. 300 into 5 is 1500 minus 300S is equal to 2 into S into S plus 5. So this minus 300 and minus 300S is cancelled, and we have this 1500 is equal to 2 into, we'll multiply this. This is S square plus 5S. This is, if we divide this thing, it becomes S square plus 5S is equal to 750. 1500 divided by 750, and S square plus 5S minus 750 is equal to 0. So you can actually use the factorization to factor this, or if you want, you can use the formula. If you are factoring it, so we need 750. If you multiply the value, we need 750, and the difference should be 5. So 25 and 5, 30. 25 into 30, 25 is 75, 750, and the difference is 5. So what we can do, this is s square plus 30s minus 25s minus 750 is equal to 0. If we take s common here, s plus 30 minus 25 common, s plus 30 is equal to 0. This is s minus 25 into s plus 30 is equal to 0. So if these multiplied, if these values are 0, then s minus 25 has to be 0, or s plus 30 has to be 0. Only then the value of this thing will be 0. So this is s is equal to 25 or s is equal to minus 30. Since the speed cannot be negative, we eliminate this option and we select this option, s is equal to 25. The correct option is D. So one way of doing this is through factorization. The another way is we can use the formula. So we know ax square plus bx plus c. If this is a quadratic equation, we know the formula as x is equal to minus b plus or minus root of b square minus 4ac upon 2a. You can do this way also. And if you follow this thing, then this becomes minus b in this case, in this equation. Sorry. Minus b is minus 5 plus or minus root of b square is 25. 5 5s are, this is b. A is here, a is 1, b is 5, c is equal to minus 750 in this equation. This is 25 minus 4, a is 1, c is minus 750 by 2a. This is 2. This is minus 5 plus or minus root of 25 plus 750. This is 3000. 750 into 2 is 1500. Another 2, it becomes 3000 by 2. This is equal to minus 5 plus or minus root of 3025 divided by 2. And this is minus 5 plus or minus, this is, I think it's 55. Square root of 50, like 3025 is 55 divided by 2. Minus 5 minus 55 by 2. One equation is minus 5 minus 55 by 2, that is equal to minus 60 by 2, that is equal to minus 30. That is one value. Or else we can take this as minus 5 plus 55 by 2. So this is 50 by 2, that is equal to 25. This is the values. I mean, this is a tough question. I mean, it is tough just because there is this equation, quadratic equation, that you have to solve. Concept wise, this is just simple. I mean, if you follow this chart, this is simple. Okay, then we'll end the session today here. Thank you for coming. We'll meet tomorrow at the same time, 8 o'clock. Thanks for coming.